Okay. Welcome to Chapter 1, Introduction to Computers and Programming. We're going to talk a little bit about hardware terminology, main memory, auxiliary memory, the definitions of drives, how to write algorithms using pseudocode. We're going to talk a little bit about PLC. We're going to talk about the how do you compile processes for non-Java programs, how do you compile them for Java programs, the difference, what object code is, what portability code is, what Java virtual machine allows you to do. Then we're going to talk about how to compile Java programs, the history of Java, and a little bit about computer ethics. Okay? How many of y'all have taken hardware class like we talked about the other day? Majority of you? Okay. Y'all know what an input device is, right? Input device is things that you can input into your system, i.e. your keyboard, your mouse, a USB pen where you can write and it will transfer data. Anything that you can use to insert information into the system, a scanner. Your output devices are going to be your monitors, your printers, anything that will take that source that's from the system unit and put it out to display it for you. Okay, that's what an output device is. Your CPU is not your box that's sitting on the floor. That is your system unit. Your CPU is just a little, probably 2-inch by 2-inch diameter chip that's sitting on the motherboard on the inside of your computer. And it correlates with the main memory. Anyone know what main memory is by definition since you read your chapter? No one? I'll take all the points away. What's main memory? What? RAM, yes. Main memory is RAM. So, what would be auxiliary memory then? Yes?
The storage devices like the hard drive.
Hard drive, USB flash drive, any other type of, you can be solid state drive, DVD, CD, things of that nature, right? These are the types of input and output devices we were talking about. CPUs are the computer's brain. In other words, it does all the computations for it. Terms is central processing unit, processor, microprocessor, things of that nature. You have two major brands, AMD and Intel, that are your major competitors for your CPUs. Basically, all it does is provide a mathematical computation and stores that data into memory. Okay? Memory, by vernacular, just means main memory or RAM. And then if you need to store it even more, you can store it into virtual memory, which is on your auxiliary memory of your drive. Thus, you remember the virtual memory or the extra memory slots you can do when you're configuring your operating system, right? Okay, that's what virtual memory is. We're going to take, for example, the word EMU. Okay, we're going to store it. Now, according to the sheet that I gave you, what is the value, the hexadecimal value of E, a capital E? 14, right? Is that what it says?
Yes.
Okay. Well, in binary, what does that mean? Every hexadecimal has 16 spaces. Okay? The E value is 14?
No. Oh, no, sorry.
It should be
45. 45, yeah.
That's what I thought.
Sorry.
Because it's like that.
Yeah.
Because you have a value of 16 here and a value of 16 here. Okay? This is how you store it in a memory. As far as this goes, a hexadecimal value gets stored over here. So if it's 4 and a 5, right? So we're going to look at 4. So how do I do this? If this slot is 1, this slot is 2, this slot is 4, this slot is 8, right? For value, they're all on, they're 16.
0, 1, 0, 2.
Right? Well, I'm sorry, it'd be 15. You have zeros, all zeros would be 0. And so when you get to all ones, then you'd be 15, so that gives you your array of 16. And then this one would be 0, 1, 0, 1. So if I'm storing the letter E in binary, that's what it stores in RAM. over 1 byte, how many bits are in a byte? 8. 8 bits, 1 byte, right? So I have my 1 byte, I have my 8 bits. Even though they're wrong on here. Oh, that's right. I'm sorry. It stores it in the other set of it. Because it's 0, 0, 0, 0, 0, 0, 0, 0. So yes, it would make it, that is correct. Because you would have EMU would store over 6 areas instead of 3. Because you would have, instead of it being that one section for that 1 byte, it actually stores it in 2 bytes length. Okay? So essentially you do have your 6 bytes to store EMU. So for every letter you hit in there is 2 bytes long. Now imagine how, now you know how quickly you fill up your memory on your document. So if you go calculate your character spaces, not that you really can't care to count it, right? RAM now, you see it goes up to about 8 gigs. On a desktop, they're now up to 32. You can get 16 gig sticks. As y'all know, RAM is volatile. Power goes out, you lose everything that was on it. But what is the term capacity? What does that mean? It means how much you can store, right? What's the capacity of a 5-gallon bucket? No, it's not. It's a little less than that. Yes, it is.
Depends on the bucket.
Exactly. Guarantee you it's not always going to be 5 gallons. Depends on how thick they make that plastic mold. If there's any air pockets in there, it could be a little bit more. All right? The average is 5 gallons. All right? Auxiliary memory. This is your hard drive. They can come in the form of disk drives. They can be flash drives. They can be solid-state drives. They can be DVDs, compact discs. They can be a variety of different things. Those are what we call storage drives. All right? It means you can store data on those disks. Pretty simple concepts, right? I'm not trying to reinvent the wheel here. Typically, hard disks go up to 3 terabytes. Wrong. Go to Best Buy, you'll see a 4 terabyte drive in there now. I mean, by the time they get these and they recreate them, they're okay. Typical flash drives up to 64 gig. I've got a couple downstairs, 3 or 4 of them downstairs that are 128 gigs. So, you know, like I said, a lot of these are a little bit out of date, but still it gets the point across. The sizes are getting bigger and bigger. Okay. CD-ROMs, they're about 714 meg to 740 meg. And you either have the 4.7 or the 8.4, not 8.5 gigabyte DVRs. And the 4.7 are DVD minus R's, your DVD plus R, which are your dual rates, are your 8.4s. So if you see them, then you'll be able to, those are what, you really can only get a dual rate plus R. You don't see minus R dual rates. You'll see minus R and plus R's for your 4.7s though. Okay? I'm not going to talk about what a drive is because y'all already know what a drive letter is. C, D, E, F, G, H, I, right? What is a program? A honey-do list, right? Set of instructions for you to do. Set of processes to solve a problem. Set of procedures. It's a step-by-step guide of how to logically perform functions. That's what a program is. They must be coherent and logically correct. Why? Because if they're not, the program will not work the way you want it to work. Remember, how many times have people say, computer only does what you tell it to do? However you program it to do it, it's going to do it. Now, it'll throw an error and say, hey, we can't do this if it's wrong. Okay? For example, if we use a cake recipe as an algorithm basically all it is, it starts out with a pseudocode, similar step by step to a regular program, but it uses regular words, layman's terms, if you will, for how the program is to operate. For example, a cake recipe: 1 egg, cake batter, 1 cup of water, and some oil. Right, 2 tablespoons of oil. I'm just guessing that's what it is. I don't remember off the back of a cake recipe. Okay, mix them all together till it's nice and all the lumps are out. 2 tablespoons of oil.
2 eggs.
Oh, is it 2 eggs? Put it in a 8x8 or a 9x9. Put it in the oven, 350 for 30 minutes, 20 to 30 minutes, depending on what kind of cake it is and what type of pan it is. Let it cool for about 15 minutes. Turn it over, then you can frost it and all this other stuff, right? That's a pseudocode. That's the logical steps on how to proceed. With the exception of one thing. I forgot to spray down the pan, right? So our cake's going to stick to the pan. Okay, let's write a algorithm that finds the average miles an hour for the car trip. We have a starting location that's 100 miles away. Our ending location, or starting location, is at mile 100. Ending location is at mile 200. Our starting time is at 2 o'clock and our ending time is at 4 o'clock. What will we do? How will we find our average miles per hour for a given car trip?
Speed equals distance divided by time.
Okay, well that's the formula. Now we know the formula, right? So we can set x to equal speed divided by time, right? Well, we got to find speed and time first, right? Distance and time. So what's our distance? It's probably our ending minus our starting, right? And our time is going to be our ending minus our starting, right? So in this instance, we now can say our miles per hour is going to equal 100 divided by 2 hours, right? So we're averaging 50 miles an hour. Yeah, I was going to say we're going slow, aren't we? Must be the back roads in Oklahoma.
Not if there's a lot of construction.
Turnpike construction in Oklahoma, that's where we're going. Okay, programming language. What is a programming language? It's going to be C, C++, Java, right? It is a set of instructions, specifically defined grammar and syntax to use these logical steps to create your program. Now we're going to talk about how do we do this with Java. Well, now that we've kind of got our syntax, let's see how we're going to do it. Initially, a programming language would be hard for anyone to understand without it developed into syntax, right? So as we get into this programming, you'll start to use the same things over and over and over, and syntax will be easy. Once you understand a programming language, any programming language after that, it's easy because you understand the logic. After writing a program, you'll normally want to have computer perform those tasks specified by the program. Basically, you got to compile it or build it. In Java, that's the term we use, is build. And then you're going to perform the run command. In other words, you're going to run the program to see if it works. You can build it successfully, not have any errors, and you can run it and it not work. Why?
Failure to put a semicolon at the end of the line.
Well, build would have catched that.
Faulty logic.
Faulty logic. Build just means it's syntax.
It's correctly coded.
It is correctly coded. The syntax is absolutely correct. There is no flaw in your syntax. The logic will prevent it from running. Okay? I.e., a while do loop that never, or you put it into a loop that never has to go through, or a case switch that never goes because it doesn't meet the criteria of the case. All right. When you perform the compile command, you tell the computer translate it into binary so it can run. All right. The computer uses this compiler to take the charge of the complementation process, and it does it 2 different ways. It takes your source code that you've created and puts it into object code. Object code is what the binary code is that the computer can run. Okay? That's what complementation does. You take your source code, which is your program, whether it's C++, C Sharp, whatever. Now Java has an intermediary, which we'll get to in just a minute, but it takes the compiler, puts it into object code, which is binary. Pretty simple concept, right? Readable, unreadable, unless you want to spend time to convert binary. Object code, like I said, it's just a binary format. It takes everything that you've learned, or everything that you've written, put it in binary code so that the CPU can do them. They're referred to as a 16-bit instruction. Why? Because it's 16-bit over here. 16-bit. And then you have an object code instruction is in charge only, simple computer task. That's all it does. It just reads it. Okay? Object code is also known as machine code to some programmers because that means the machine is operating it. Does that make sense? Now Java, the difference between Java and the rest of them is Java is portable. Y'all realize that, right? Because every machine has Java runtime environment. You have all these applications that say, hey, I need Java, need to update Java, need to update Java. It's because it's running on Java runtime environment. What that means is I made my code, I take it from source and I put it into what we call bytecode. I send the bytecode to the computer, to your computer then compiles it to your local machine so your local machine can run it at that point. Because it becomes hardware dependent on that local machine rather than anywhere else. And that's why Java programs are favored highly over a lot of other ones because they're specific to the computer they use. Does that make sense? For example, C++ program can only be compiled on the machine it's written on. Or the program that it's using. Like if I'm doing a Visual Studio, I have to have Visual Studio. Where I don't have to have Visual Studio if I'm writing a Java program on every computer. How many of you are going to spend $2,000 for a product just to run a program? Nah, didn't think so. That's why Java runtime environment's free. It's just, it's an emulator is all it really is. Okay? Now Java virtual machine runs bytecode. So you take this Java source code that we write, the Java compiler, once you build it and run it, or once you build it, puts it into bytecode. That bytecode is what gets sent out in these programs. Then your computer, when you run that, runs it in object code or the machine code so that you can actually run it on your local machine. That's the difference between Java and the rest of the programming languages. Okay. In the 1990s, people started putting technology into what? In the 90s, people started putting technology into home appliances. Yes, Matthew?
I was going to say home appliances, refrigerators, etc.
Mm-hmm. And they wanted to call it a hot technology. Why? Because they were thinking programmable coffee makers, right? Y'all remember when they started coming out? I could set my alarm, y'all probably all elementary school.
That where it's like you can tell it which time you want it to turn on. So.
Yeah, it's a Java code in there.
Yeah.
Because it can be stored on a very little amount of ROM. That's what those were programmed with. So that's why it was a hot appliance. Lights were controlled remotely with Java. TVs could be controlled interactively with remotes. It was kind of cool, right? Instead of infrared, it was doing by Java. Then Sun Microsystems bought Java out in 91. It was codenamed Green at the time. To make it more into intelligent home appliances. Well, who did Sun get bought out by? Oracle. Now Oracle owns Java. And there's a lot more things that they're trying to do with it.
And they're killing it.
Yeah.
In lieu of what?
Sun originally wanted to use C++ for these home appliances. But they found it was less than ideal because why? Cost. It was hard to maintain. You couldn't keep up with it. There's a lot of deficiencies. So their new language, called Oak, was changed to Java, and that's where it got its name after it became designed. Then Java got its real experience when it started doing World Wide Web applications. Because web are what? Websites are portable. Let's use Java, which is portable. Now we can do what things? Called apps. Now we have applets. Now Adobe got their hands into it. Now a lot of things are being done with Adobe, Flash, Microsoft Silverlight, and Java's collapsing. Okay? The standard edition of Java, the SE, are basically your applications. In 2010, Sun was acquired by Oracle so that Oracle can do what they want to with Java. But it still helps, and it's so widely used that Oracle can't get away from it for right now until something better comes along. As in computers, there are certain things that you need to know, especially those that are in cybersecurity. Thou shalt not use a computer to harm other people. How many of y'all have done that? Thou shalt not interfere with other people's computer work. Okay. Thou shalt not snoop around in other people's computer files. Okay. Anyone that's in a relationship that's violated number 3. Thou shalt not use a computer to steal. How many of you have actually downloaded a single piece of software or music? Raise your hand. Yeah, right. Thou shalt not use a computer to bear false witness. This is what gets a lot of people in trouble. You know, if you put a phony name out there on create a Facebook page that's not yours, or change your identity on Facebook, you're bearing false witness. If they find that out about you in this field, you can be out of this field. Unless you're working for the CIA or the FBI and it's a cover and they need you to do it, and all sorts. You know, if you work for the government, there's all sorts of excuses. And thou shalt not copy or use proprietary software for which you have not paid. Thou shalt not use other people's computer resources without authorization or proper compensation. How many of you have stolen Wi-Fi's from next door neighbors to download P2P stuff?
I don't have neighbors.
Our neighbors are stealing our Wi-Fi.
That's who's stealing your Wi-Fi right there. Thou shalt not appropriate other people's intellectual output. In other words, thou shalt not commit plagiarism. Thou shalt not cheat.
Thou shalt not use WordPress.
Thou shalt not think about social consequences of the program you're writing. Did I say thou shalt not think? That would actually be good ethic, right? Thou shalt think about the social consequences of the program you were writing or the system you were designing.
Don't make Skynet.
I.e., Facebook didn't think about it, did they?
Nope.
Cyberbullying. They didn't think about what they caused. They brought in a whole new way of terrorization.
And they should be sued.
They are. They will never lose. Because, according to their EULA agreement, anything you put on there is theirs.
Mm-hmm. That means that they're the ones that are committing the crime,
But
not the perpetrator.
But you know what they're going to say? It's my First Amendment right to post what I want to. And they got around it. Trust me. They've got so many outs on it, it's not even funny. Until Congress passes a law that says this, and then they sue them in between before the Supreme Court can overturn it, and they get slapped with the fine beforehand.
Everybody wait for that time.
And then everyone jump in on a class action lawsuit right then.
They just stay away from Facebook.
Thou shalt always use a computer in ways to ensure consideration and respect for your fellow humans. That means don't use them. Right? Because you turn it on, you're going to be a victim of a zombie attack that's going to hurt someone else, right? A lot of these things seem simplistic, but there are a lot of things you need to think about, right? That we don't normally think about. Is there any questions on those? All right, ready? Pseudocode is what? Is often used when writing an algorithm. Java programs can be embedded in web pages, and such as programs are called. I didn't create these slides, by the way, so don't blame me for the sound. If you submit your homework 2 class periods late without a signed excuse or a no penalty coupon, which I don't have, what is the penalty?
Depends on the professor, but
You will receive a 0. What did I say? I have no late policy, right? Y'all didn't read my syllabus? I'm still waiting for y'all to read C.
I saw it. I'm just like, what is that? What's the devil's information?
The author who wrote these slides is a little quirky.
was Ken who wrote this?
No, it was John Dean. I work with him at Park. Now you will receive a 0 on your homework and a 0 on any previous, and in my class also on your next assignment. And plus I may expel you.
Plus you let it know too.
And then I tell everyone in all my classes that I caught you. So no one's going to want to work with you. So you get hurt in multiple ways, right? Just don't get caught cheating. And when I say I tell people in other classes, I don't tell them your name. I just say I caught someone in my room. Because I'm not going to break FERPA and tell them your name.
That's ironic. You don't say don't cheat. You said don't get caught cheating.
Yeah, I know.
But here's the thing. Try me.
No, thank you.
Matthew knows better than trying to catch me. Let me catch him, right?
I haven't been caught. I haven't cheated, but I know better.
I was about to say, I haven't been caught yet.
I know I caught it too. I'm going to be watching his assignments. All right. Any questions?
Can I see the previous slide? Thank you.
No problem. Any questions?